Uh, uh, Today we're going to talk about the volume of prisms and cylinders. Our EQs, what are the formula for prisms and cylinders? We're going to try and learn and apply the formula for the volume of a prism, learn and apply the formula for the volume of a cylinder. Our key terms are volume and Cavallari's principle. Right? First up, the volume of a three-dimensional figure. Okay, here's what you need to write down. The volume of a three-dimensional figure is the number of non-overlapping unit cubes of a given size that will exactly fill the interior. Right? That's the only part you need to write down. Now, we'll talk about Cavallari's principle in just a little bit. Cavallari's principle says if two three-dimensional figures have the same height and have the same cross-sectional area at every level, they have the same volume. What I mean? Let's start simple. I mean this. We're going to talk about the volume of prisms. You need to write these three formulas down. Prism with a base area B and a height of h is big B times h. That one's the most confusing. The volume of a triangular prism, big B represents the area of the triangle, h represents the added height dimension. Okay, that's the tough one. The other two are pretty easy. To find the volume of a rectangular prism, you multiply length times width times height. Okay, because if you multiply a height in there, you're taking it to the third dimension. A cube is simply this. It's when I take a square, right? I take a square and I add in a third dimension of height that is equal to the size of the square, okay? If I had one side, if I just drew one line, we'd call that a side. We call that a line, really, okay? Doesn't have any dimensions. If I create a square, I have two dimensions, right? We find the area of that square taking side times side. We call it a square because, how do I say this right here? S what? S squared, right? Y'all want to know why we call this cube? This is called S cubed, okay? S to the third power, S cubed, right? Really pretty simple concepts, right? We'll discuss them a little bit more in depth. Here's what we mean. Real simple, right? Find the volume of this prism rounded to the nearest tenth if necessary. So, base, let's call it, what kind of prism is it? Identify it. A rectangular prism. You multiply length times width times height. Length times width times height. Everybody got me? Length times width times height. Okay? So in this case, 13 times 3 times 5. 195. Can't make it easier. Notice what dimension I put on the end of the units. Cubic centimeters, right? You put a 3 there. Why do you think you put a 3? What's that? How many times did we multiply? How many dimensions did we multiply? 3 of them, right? Remember, if it's an area, you put area squared because you multiplied 2 dimensions, correct? You multiply 3 dimensions, you put a 3. Do not put centimeters squared. Don't put a 2 right here, okay? Because that's wrong. That's not the volume. That's the area. You're wrong, okay? Volume will deal with 3 dimensions. You guys try. Right? Find the volume of a triangular prism with a height of 9 whose base is a right triangle with legs of 7 and 5. Tell you what, I'll help you out with this. Mr. Reveau, how do I find the volume of a triangular prism? big B, right? Capital B times H. Okay? Here's what you need to know. Here is your secret to these problems. When you see big B, that tells you calculate the area of the two-dimensional figure. And what kind of two-dimensional figure do you think I'm dealing with here? A triangle. Now look at your formula sheet. How do you find the area of a triangle? It's 1/2 base times height, right? 1/2 base times height, okay? So check it out. To get the area of this right triangle, you need to take 1/2 of 7 times 5. So your big B in this case, big B equals 1/2 of 7 times 5. Vo, what is 7 times 5? 35. What's half of 35? Do you have something that would help you figure that out? $17.5, right, Kate? Okay. Now, check it out. Now that you got this, you're ready to roll, right? Okay. What is the height of this triangle?
7.
No.
17.
No.
5.
No. Read the problem. 9. Which means my volume is what? 17.5 times 9. 157.5. Now, Cade, when I put yards, what number's going to go up there? A what?
2.
Why is it not a 2? How many dimensions am I dealing with here? 3. Not 2 dimensions, but 3 dimensions, okay? Guys, I'm not lying. You can do all the math right. If you put a 2 right there and not a 3, it's wrong. And it'll be counted wrong. Okay? Because your answer's not right. Got me? This is part of, this tells me I know what the heck I'm doing when I calculate volume. Alright? This tells me I paid attention. I know I'm dealing with 3 dimensions, so I've got to put a cube right there. Am I with me on that? Okay? Yes, it matters. Yes, it makes a difference. Any questions on that one? Okay. Alright. I love this. The swimming pool is a rectangular prism. Estimate the volume of water in the pool in gallons when it is completely full. Hint, 1 gallon is approximately 0.134 cubic feet. The density of water is about 8.33 pounds per gallon. Estimate the weight of the water in pounds. Yeah, right? What? Check it out. First, find the volume of the swimming pool. If the swimming pool, oh, by the way, this should be 9. Okay? If the swimming pool has dimensions of 25, 15, and 9, what do I do with those 3 numbers? You multiply them. Length times width times height, right? Length times width times height. If you multiply 25 times 15 times 9, you should get 3,375 cubic feet, right? Now, y'all did conversions last year, correct? Now you're going to convert, guys. Convert from feet to gallons. Everybody in your calculator right now, please do this for me to make sure you remember how to do it. 3,375 times, and then put that fraction in there. 1 over 0.134. And see if you get 25,186.57. Did you get that? Keep that in your calculator for right now. Use it again. Alright? If you didn't get that, you need help multiplying the fractions, let me know. Show you how to do it. Everybody with me? So you just understand what we did here. We took cubic feet and converted it to gallons, right? Okay, we got one more conversion because I got to take those gallons and convert them to pounds, all right? So take the gallons that you just entered into your calculator, that you just calculated, and multiply that by this conversion, 8.33 over 1. So 186.57 times, if you want to just put 8.33, you can. And you should get approximately 209,804. Okay? Who's got that? Good deal. I got it? All right. Cool. So if you want to know, if you ever get into a swimming pool that 25 feet by 15 feet by 9 feet deep, okay, just think there's almost a quarter of a million pounds of water. Pretty heavy. Yo. Well, you know what? That's a good question. We'll get to that. We won't do that exact problem. We call that a composite figure. Okay? And what I would do in that is I would calculate just like they do here, okay? I would calculate the entire prism, okay, and make it like a prism, and then I would calculate the decline, okay, and I would subtract whatever's declining out from the entire prism, okay? Not a bad question, all right? Then we get to this, all right? This is Cavallari's principle. Cavallari's principle relates to cylinders as well as it does prisms, and here, guys, here it is in a nutshell. Cavallari's principle says if I've got two figures and those two figures have the same area and the same height, they have to have the same volume. It doesn't matter if it's leaning over and one of them's straight up and down. If they have the same area and the same height, they must have the same volume. This is always on your EOC. I promise you, you will get one question like this on your EOC, and you better get it right because it's an easy one, okay? You're going to get two figures. One of them's going to be straight up and down. The other one's going to be leaning, and it's not going to look like it, okay? And you got to remember, if they have the same area and the same height, yes, indeed, they have the same volume. So with me? Okay? How might it be presented to you? Probably something like this. Okay? Probably they'll have a cylinder, or they could have, you know what? They could have some sort of rectangular prism. I always mess this up. Did I already do it? They usually have cylinders. Okay? Usually they got something like this. Okay? There's one cylinder, and then they got another cylinder, and it's like, ooh, man. So, this is cylinder A, and this one's B. Okay? And it'll say this. It'll say the radius of A is 8, and the radius of B is 8, and the height of A, so the height of A is 12, and the height of B is also 12. True or false? They have the same volume. It's true. Okay? It's true. Guys, if they have the same radius, they have to have the same area, right? Pi times radius squared, area of a circle. Pi times radius squared. If the radius is 8 here and it's 8 here, they have the same base. Do they have the same height? Yeah. Think about what the principle says. The principle is this. If they have the same area and they have the same height, they have the same volume. Okay? I don't care what it looks like. It has to be true. Does anybody know what the Leaning Tower of Pisa is? Does anybody know what the Leaning Tower of Pisa is? You poor kids. Lights, please. Now, the Leaning Tower of Pisa would apply here, but you guys understand what I mean when I say if something's leaning over, it's not going to make a difference about volume as long as it has the same base area and the same base height as a structure that was straight up and down. Everybody got me? Okay? It's a strange principle, I know, but it's true. Okay? It's one of those things that they test on every single year. They ask you that every year. You guys are going to kill it, okay? Y'all going to be fine with it. Same thing, and you saw the slide earlier. If it's a rectangular prism, and it's like cards in a deck or leaning over, right? Again, if it has the same area and it has the same height, it's got the same volume. Are you with me on that? All right, cool. All right. How do we find the volume? Oh, did y'all write this down? Volume of a cylinder? Hopefully you wrote this down. Volume of a cylinder. How do we find the volume of a cylinder? Well, it's going to be big B times H. Mr. Vo, when it says big B, that means the area of the two-dimensional figure. Okay? Mm-hmm. In this case, for the cylinder, what figure is the second dimension?
The bottom.
Okay, and what shape is at the bottom?
Circle.
A circle. How do you find the area of a circle?
Pi. Radius squared.
You hear him? You find the area of a circle with pi times radius squared. So the big B, when you're dealing with a cylinder, is pi r squared. And then remember, the whole point of volume, you add, you multiply in a height dimension. Okay? Y'all with me on that? You take pi radius squared, that would give you the area of the circle, times an added height dimension, that gives you the area of your cylinder. Miss Miller, what base is at the bottom of your cup? What kind of base is it? Can you pour it on your head? What shape is this? A circle. If you wanted to take the volume of your bottle, you would find the area of the circle and multiply it by the height, right? All right, right here, Miss Miller, what is the radius of this circle? What'd you say? Perfect. Why didn't you say it was 18? Yeah, 18's the diameter, correct? If 18's the diameter, what's the radius? 9, half of the diameter, right? So this is just simply pi times 9 squared times 14. I mean, it's really simple math, right? Y'all with me on that? That's why I think we can do this in 2 days, okay? It's really simple stuff, just a couple things we got to highlight here and there. All right, like one of these. Find the volume of a cylinder with the base area of 121 pi square centimeters and a height equal to twice the radius. Give your answer in terms of pi and round it to the nearest 10. Whoa, boss. The volume of a cylinder that has a base area of 121 square centimeters. All right, a cylinder has what type of shape at the base? A circle. The area of a circle is what? Formula. Pi radius squared, correct? And this tells me that the area is 121 pi, right? Okay. I don't know what the height is. I'm looking for big base times height, correct? You with me? No? Yes? Is this the big base? Say it, Alex. Yeah. It tells me what the big base is, right? This tells me 121 pi is your big base. What's the problem? I don't have a height, right? I don't know what h is. I got to read the problem. How do I figure out what h is? H is equal to what? So I need to find the radius, double it, and I'll have my height, correct? Go with me? Let's find the radius here. Divide both sides by pi. The pi's cancel out. You get 121 equals r squared. Faith, how do I solve for r there? Do what? No! Did you say divide? Woo! Square root. Tuesday morning is early. Woo! Well, I'll tell you one thing. Woo! Yeah. You about gave me a heart attack. I mean, I'm your math teacher. You're still dividing by 2, and we got powers of 2 up there. Faith, if the radius is 11 and the height is twice the radius, how much is the height? The radius is 11. The height is twice the radius. How much is the height? What? I got big ears, but I can't hear them when you whisper. 22! So 22 is the height. If you want to know the volume, do 121 pi times 22. Scared me. He's really scared me. I thought we were going backwards. All right. Here's what we did, right? We took pi times radius squared, set it equal to 121 pi, divided both sides by pi, took the square root of both sides to get 11. Since the height is twice the radius, to find the height, we did 2 times 11. Use the radius and height to find the volume. We took the volume of the cylinder. To do that, we do pi times radius squared times height. Remember that 121 pi is going to be the same thing as pi times 11 squared. Okay? It gave us the big B. Y'all got that? You were already given that information in the first problem. You multiply that times 22. Mr. Vo, if this is a volume, I'm going to have what right there? Yeah, cubic centimeters, right? Not a 2, but a 3. Are with me? Because you got 3 dimensions you're worried about. Okay? You're going to have a couple. I got 2 more slides, guys. That's it. Okay? You're going to have a couple of. Hey, Sutter. Yep. Sutter, tell me this. The radius and height of a cylinder multiplied by 2/3 describe the effect of the volume. I almost called you. I almost did. Maddie. I almost called you Maddie. Maddie, what's the radius of this cylinder? What's the height? Before I do anything with the dimensions, find the original volume. Pi times 24 squared times 33. You'll get 19,008 pi. Okay? Go with me on that? Then you go back. You multiply both of these dimensions by 2/3. What's 2/3 of 24? 16. What's 2/3 of 33? 22. Are these things on the slides?
Yes.
Yes, they are. Okay. We'll get there one day. All right. Then you do pi times 16 squared times 22. You get 5632 pi as your volume. Now it wants you to describe the effect. Well, here we go. 5632 pi equals 8/27 of 19,008 pi. If the radius and the height are multiplied by 2/3, the volume is multiplied by 2/3 to the 3rd power, or 8/27. Okay? Alright, how is it getting that? Here's how. Take 2/3. Guys, what's 2 times 2 times 2? 2 times 2 times 2 is 8. What's 3 times 3 times 3? That's how it's getting it. Okay? You got me? That's how it's getting that particular dimensions. right? You won't get asked, I don't think it'll go that extensive in your questions, but we'll have one or two like it. Last thing is called a composite figure. Hear me out on this. You have a composite figure. Here's what you need to do. Let me give you an example of one. Our house is a composite figure, I hope so. Alright? Pipe. Here's a composite figure, if I may. Okay? What's the volume of that composite figure? That's what it's going to ask. You hear me? The volume of this particular composite figure. Here's how you do it. Find the volume of this rectangular prism. Find the volume of this rectangular prism and add them together. That's it. Got me? Okay? Most of the time, you might see it like this. What's the volume of this composite figure? Well, take the volume of this cylinder, take the volume of this cylinder, add the volumes together. Okay? In this case, look what it does on the board. It has a triangular prism with a rectangular prism. Take the volume of the rectangular prism, 8 times 4 times 5, okay? And then you're going to have to take the base area of the rectangular prism. They calculate it as 1/2 of 8 times 4 to the square root of 3, okay? I put much easier ones on there today, all right? Multiply that times your height, you get this, 16 to the square root of 3. Guys, if you calculate these two volumes individually and then add them together, you get a sum of 270.9, okay? Composite figures are real simple. You're going to have a constructive response question on Friday that has a composite figure, all right? I promise you. Y'all can kill it, you'll knock it out of the park. Every time you see a figure, take the volume of it, take the volume of it, take the volume of it, add those volumes together. Everybody with me? Okay?